Hello friends, welcome to my YouTube channel Get Code. Today we will discuss about slope and deflection of different type of beams through a simple trick. Okay, it is not easy to memorize slope and deflection of different type of beams one at a time, so we will memorize it easily through a simple trick. I hope you will like it. In first situation, we have given a cantilever beam. A moment is applied at the end point of the beam and the length of the beam is given as L. In second situation, we have given a cantilever beam. A concentrated load is applied at the end point of the beam and the length of the beam is given as L. In third situation, we have given a cantilever beam. A uniformly distributed load is applied throughout the beam and the length of the beam is given as L. Fourth situation, we have given a cantilever beam and uniformly varying load UVL is distributed throughout the beam and the length of the beam is given as L. In fifth situation, we have given a simply supported beam and a concentrated load is applied at the midpoint of the beam. Okay, the length of the beam is given as L. The length between this point and this point is L by 2 and this point and this point is L by 2. Okay. In sixth situation, we have given a simply supported beam and a uniformly distributed load is applied throughout the beam and the length of the beam is given as capital L. Okay, capital L or small l. You have to remember all of the 6 situations serially. Okay, you have to remember all of the 6 situations serially. We will discuss all of the situations one by one. In first situation, we have given a cantilever beam and a moment is applied at the end point of the beam and the length of the beam is given as L. The maximum bending moment will be M. In second situation, we have given a cantilever beam. A concentrated load is applied at the end point of the beam and the length of the beam is given as L. So the maximum bending moment will be WL. W into length L. WL. In third situation, we have given a cantilever beam and a uniformly distributed load W is applied throughout the beam. The maximum bending moment will be WL square by 2. Okay. In fourth situation, we have given a cantilever beam and uniformly varying load W is applied throughout the beam. The maximum bending moment will be WL square by 6. In fifth situation, we have given a simply supported beam. Okay, a concentrated load is applied at the midpoint of the beam. So the maximum bending moment will be WL by 4. In sixth situation, we have given a simply supported beam and a uniformly distributed load W is applied throughout the beam and the length of the beam is L. So the maximum bending moment will be WL square by 8. To remember slope, we have to remember some formulas serially. Okay. For first situation, theta equal to ml by ei. Here m is the maximum bending moment. Okay. L is the length of the beam. E is the flexural rigidity. Okay. Theta equal to ml by ei. For second situation, theta equal to ml by 2 ei. For third situation, theta equal to ml by 3 ei. Okay. For fourth situation, theta equal to ml by 4 ei. For fifth situation, theta equal to ml by 4 ei, and for the sixth situation, theta equal to ml by 3 ei. Okay. For first situation, theta equal to ml by ei. Second situation, theta equal to ml by 2 ei. For third situation, theta equal to ml by 3 ei. For fourth situation, ml by 4 ei. For fifth situation, theta equal to ml by 4 ei, and for the sixth situation, theta equal to ml by 3 ei. Okay. To remember slope, we have to remember some formulas serially. Okay. For the first situation, theta equal to ml by ei. Here m is the maximum bending moment, L is the length of the beam, and ei is the flexural rigidity. Okay. For the second situation, theta equal to ml by 2 ei. Okay. For the third situation, theta equal to ml by 3 ei. For the fourth situation, theta equal to ml by 4 ei. For the fifth situation, ml by 4 ei, and for the sixth situation, theta equal to ml by 3 ei. For the first situation, theta equal to ml by ei, we will put m as capital M. So we will get theta is equal to ml by ei. In the second situation, theta equal to ml by 2 ei, we will put m is wl. So we will get theta is equal to wl square by 2 ei. In the third situation, theta equal to ml by 3 ei, we will put m is equal to wl square by 2. Then we will get theta is equal to WLQ whole divided by 6 EI. In the fourth situation, theta is equal to ML by 4 EI. We will put M is equal to WL square whole divided by 6. Then we will get theta is equal to WLQ whole divided by 24 EI. In the fifth situation, theta is equal to ML by 4 EI. We will put M is equal to WL by 4. Then we will get theta is equal to WL square whole divided by 16 EI. In the sixth situation, theta is equal to ml by 3 ei. Okay, we will put m is equal to wl square by 8. Then we will get theta is equal to wlq whole divided by 24 ei. Okay, to remember deflection, we have to remember some formulas serially. Okay, we have denoted deflection as del. So del is equal to theta into L by 2. For the second situation, del is equal to theta into 2L by 3. For the third situation, del is equal to theta into 3L by 4. For the fourth situation, del is equal to theta into 4L by 5. For the fifth situation, del is equal to theta into L by 3. For the sixth situation, del is equal to theta into 5L by 6. Okay. Here theta is the slope. Theta is nothing but slope. Okay. L is the length of the beam. For the first situation, del is equal to theta into L by 2. Theta is ml by ei. So we will get del is equal to ml square whole divided by 24 ei. For the second situation, del is equal to theta into 2L by 3. We have got theta is equal to wl square whole divided by 2 ei. Then we will get del is equal to wlq whole divided by 3 ei. For the third situation, del is equal to theta into 3L by 4. We have got theta is equal to WLQ whole divided by 6 EI. So we will get del is equal to WL4 whole divided by 8 EI. For the fourth situation, del is equal to theta into 4L by 5. We have got theta is equal to WLQ whole divided by 24 EI. Then we will get del is equal to WL4 whole divided by 30 EI. For the fifth situation, we have got theta is equal to WLQ whole divided by 16 EI. Then del is equal to theta into L by 3. We will put theta is equal to WL square whole divided by 16 EI. Then we will get del is equal to WLQ whole divided by 48 EI. For the sixth situation, theta is equal to WLQ whole divided by 24 EI. Del is equal to theta into 5L by 16. We will put theta is equal to WLQ whole divided by 24 EI. Then we will get del is equal to 5WL to the power 4 whole divided by 384 EI. We will discuss all of the situations one at a time. Okay. For the first situation, maximum bending moment will be m. Slope is equal to theta equal to ml by ei. So we will put m is equal to capital M. Then we will get theta is equal to ml by ei. For the second situation, maximum bending moment is wl. So theta is equal to ml by 2 ei. We will put m is equal to wl. Then we will get theta is equal to wl square whole divided by 2 ei. For the third situation, maximum bending moment is wl square by 2. The slope is equal to ml by 3 ei. We will put m is equal to wl square by 2. Then we will get theta is equal to wlq whole divided by 6 ei. For the fourth situation, maximum bending moment is wl square by 6. The slope is theta is equal to ml by 4 ei. We will put m is equal to wl square by 6. Then we will get theta is equal to wlq whole divided by 24 ei. For the fifth situation, maximum bending moment is wl by 4. Then theta is equal to ml by 4 ei. So we will put m is equal to wl by 4. Then we will get theta is equal to wl square whole divided by 16 ei. For the sixth situation, slope is equal to theta is equal to ml by 3 ei. We will put m is equal to wl square whole divided by 8. Then we will get theta is equal to wlq whole divided by 24 ei. For the deflection, del is equal to theta into L by 2. Theta is nothing but slope. We will put theta is equal to ml by ei. Then we will get del is equal to ml square whole divided by 2 ei. For the second situation, del is equal to theta into 12 by 3. Theta is equal to WL square whole divided by 2EI. Then we will get del is equal to WL cube whole divided by 3EI. For the third situation, theta is equal to ML by 3EI. Then we will put m value WL square whole divided by 2. Then we will get theta is equal to WL cube whole divided by 6EI. Now del is equal to theta into 3L by 4. We will put theta is equal to WL cube whole divided by 6EI. Then we will get del is equal to WL4 whole divided by 8EI. For the fourth situation, del is equal to theta into 4L by 5. We will put theta is equal to WL cube whole divided by 24EI. Then we will get del is equal to WL4 whole divided by 30EI. For the fifth situation, del is equal to theta into L by 3. We will put theta is equal to WL square whole divided by 16EI. Then we will get del is equal to WL cube whole divided by 48EI. For the sixth situation, del is equal to theta into 5L by 6. The theta value equal to WL cube whole divided by 24EI. Then we will get del is equal to 5 WL to the power 4 whole divided by 384EI. Thanks for watching. I hope you will like it. Thank you.